Prior to discussing the announcement, it is essential to comprehend what particle accelerators are. The Large Hadron Collider, LHC, which CERN operates, is a 17-mile-long superconducting magnet ring and the largest, most powerful particle accelerator. It symbolizes the highest level of human achievement in science. In point of fact, it is powerful enough to recreate the circumstances of the universe's birth. Could this apparatus be used to unlock the key to the universe's secrets? A much more unsettling scar lies within. Established in 1954, CERN is one of the most reputable research institutions, with 23 member nations and thousands of scientists. It is the hub for innovation and collaboration. The LHC is CERN's flagship project, but it's only a component of an extensive network of experiments and accelerators. Picture a racetrack, not for horses or cars, but for subatomic particles, competing with the LHC in both time and space itself. Protons are sped up to nearly the speed of light, causing them to collide in a course that imitates the intensity of the universe when the Big Bang occurred. The temperatures caused by these collisions are more than 1,000,000 times hotter than the core of the Sun. Protons are guided by thousands of magnets as they travel through intricate systems. The magnets are kept at temperatures below those of space by cooling systems. Inside the LHC, collisions are made between beams at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS, Alice, and LHCb. Each serves a distinct function, exploring various aspects of particle physics. Combined, they are enormous cameras that take pictures of these collisions. Scientists then sort through the debris, seeking evidence of the elusive Higgs boson, also known as the God particle, and other phenomena that provide hints about the fundamental elements of the universe. Through studying the microcosm, we learn more about the macrocosm. However, with each response comes a new inquiry, and with each discovery, a new difficulty. The LHC is not simply a scientific instrument. It serves as proof of human inventiveness and curiosity. It embodies our relentless pursuit of knowledge and the need to comprehend the fundamental factors that shape our universe. But as we test these limits, we must also consider the questions of ethics and existence that arise. What are the dangers of questioning the unknown? Could our search for understanding accidentally unleash forces in the hallowed halls of CERN that we can't control? Where the boundaries of human comprehension are constantly pushed, a new revelation has come to light. Even the most seasoned scientist, Brian Cox, a former CERN researcher and an authority in the particle physics world, has made an announcement that has left history both frightened and fascinated. Cox's words reverberate with haunting clarity. The Large Hadron Collider at CERN is to recreate a miniature Big Bang. That's right, a miniature version of the very thing that led to our universe, the physicist added, enumerating the ramifications of this objective and highlighting the remarkable features of the LHC's potential for discovery. This includes its capacity to unlock the secrets of the Higgs boson and a mysterious substance known as dark matter, a significant component of the universe. Picture yourself wielding the power of creation under your control, the capacity to conjure the very essence of the universe. It's a tempting but dangerous possibility. The miniature Big Bang is not only a theoretical idea, but an observable reality at the LHC. The temperatures, pressures, and raw energy mimic the conditions at the beginning of the universe. It's like standing at the dawn of time, at the birth of existence itself. But with such strength comes accountability, and the question looms, what happens if something goes wrong? In fact, something terribly went wrong. In 1978, Anatoly Bugorsky, a Russian physicist, experienced an incident that would forever alter his life's course while working on the U-70 synchrotron at the Institute of High-Energy Physics in Russia. An error resulted in his head accidentally crossing the path of a proton beam. The forceful beam, beyond comprehension, traveled through his skull, entering the back of his head and exiting through his nose. His experience was unlike any other. He saw a flash with the brightness of 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through bone and tissue, yet he remained conscious, even attempting to walk to the clinic for treatment. The repercussions were both fascinating and horrifying. The beam's path led to localized tissue death, resulting in partial facial and ear paralysis and the loss of hearing in one ear. Astonishingly, Bugorsky's intellectual capabilities remained unaltered, and he continued his work as a scientist. This incident is not simply an individual tragedy, but a cautionary example that highlights the enormous power and potential dangers of particle accelerators. Particle accelerators like the LHC are not to be underestimated. The potential for unanticipated reactions, manipulating the very fabric of space and time, is not science fiction, but a real concern expressed by some in the scientific community. One of the most troubling and intriguing issues associated with LHC experiments is the potential to create a miniature black hole. A black hole is a region of space-time with such strong gravity that nothing, not even light, can escape. These cosmic vacuum cleaners that consume stars are mysterious entities, lurking in the shadows of our universe. The idea that such an entity could be created by the LHC, even on a microscopic scale, is shocking to both laypeople and professionals alike. Could this black hole expand, swallowing the Earth out of control? Despite assurances from CERN researchers that any such black hole would be unstable and disappear almost immediately, the mere possibility has sparked arguments, anxieties, and awe due to the power we wield. To comprehend how the LHC might produce a black hole, we must consider the fundamentals of particle accelerators. When protons collide at speeds close to light, the energy released is so great that it alters the very fabric of space itself. Imagine a tightly stretched trampoline with a heavy weight placed on it. The fabric flexes, and if the weight is sufficient, it could create a depression so severe that anything nearby would be drawn in. That's a stylistic illustration of what might happen in the quantum physics of the LHC. In physics, there is a belief that extra dimensions may be concealed within our reality. The LHC's collisions could theoretically tap into these dimensions, leading to a funnel of gravitational pull that results in a mysterious microscopic black hole. This idea has captured the attention of renowned researchers, including the late Stephen Hawking, who warned in his book of a possible scenario where the Higgs boson becomes unstable at very high energy levels. This fluctuation could result in a cosmic event, catastrophic vacuum decay that would endanger not only Earth but the entire universe. The highly regarded British cosmologist Sir Martin Rees also expressed concerns about the experiments performed at CERN. In his book on the prospects for humanity's future, he investigated the potential dangers of particle accelerator experiments. His words were more than cautionary. They were infused with existential terror. He described a worst-case scenario where a disastrous experiment might create an unstable vacuum state. This instability could, in theory, cause a phase change that would spread throughout the fabric of space-time, resulting in a cosmic calamity with the potential to engulf the entire universe. Rees's worries were not restricted to theoretical reflections. He assigned a small but non-zero probability to these catastrophic results. However, he argued that even a minuscule chance ought to give us pause. The stakes are unimaginably high, and the margin for error is very small. Scientists at CERN have calculated the odds, conducted simulations, and investigated theories that support the safety of the LHC. In fact, Brian Cox himself recognized the significance of responsible investigation, acknowledging the worries and fears surrounding the LHC's operations. He stressed that strict safety measures, extensive procedures, and checks ensure the LHC's operations are carried out with the highest level of care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the likelihood of creating a stable black hole is extremely low. Even if one were created, scientists predict it would be so fragile and small that it would disappear in a flurry of energy, a phenomenon referred to as Hawking radiation, a fleeting glimpse of cosmic wonder that vanishes into the depths. Some have speculated further that the LHC's experiments might open the door to another dimension or universe. This notion, though largely dismissed by the scientific community, has captured many people's imaginations and evolved into a matter that fascinates, scares, and even inspires folklore. What lies beyond what we see? Could we accidentally activate forces or entities we are unable to comprehend? The concept of opening a door to hell has even generated sensationalism in various media, contributing to the blaze of uncertainty. How did this idea originate, and what does it mean in the context of scientific investigation? Parallel dimensions are not a new concept in physics. String theory, a potential framework for a unified theory of everything, suggests additional dimensions beyond the usual 3 of space and 1 of time. These extra dimensions may be compressed or hidden from view, but could, in theory, be accessed or revealed in extreme circumstances. Imagine the LHC as a cosmic key, unlocking sealed doors since accelerators that unlock the mysteries of the universe have made more people concerned about the potential dangers and effects that such experiments have. In the end, the LHC remains a potent symbol of human ambition and curiosity. It is a testimony to our progress to date in comprehending the universe, as well as a reminder of the risks associated with this understanding. The universe may be vast. However, the more we learn about it, the more we become aware of how little we actually comprehend. The pursuit of knowledge is one of the greatest achievements of humanity. But there are also a lot of unknowns and dangers. Only time will reveal whether we are prepared for the next discovery. The Large Hadron Collider, also known as the pinnacle of science and technology today, not only opens the door to inquiries, but also re-examines the very foundation of our comprehension of the universe. The machine itself is an engineering masterpiece, spanning an enormous underground ring and featuring the most precise and advanced equipment ever constructed. It brings together a global network of researchers and scientists who are united in their quest to answer some of the most fundamental questions about the universe. However, as scientists test the limits of human understanding, they face significant obstacles, both ethically and theoretically. One of the LHC's primary focuses is the endeavor to comprehend the forces that govern the universe. For hundreds of years, researchers have attempted to unravel the complexities of gravity, strong and weak electromagnetism, and nuclear forces. The LHC offers an unprecedented chance to investigate these forces under extreme conditions. Particles, colliding at such high energies, imitate conditions existing just a few seconds after the Big Bang, when the universe was a steaming, dense soup of particles. Because of this, researchers can investigate the behavior of energy and matter in ways that were previously thought impossible. Despite the fact that the LHC could be used to make groundbreaking discoveries, it also raises significant concerns regarding the limits of experimental science. The chance to learn something new, supersymmetric particles, for example, or dark matter particles, could radically alter our perception of the universe, but these findings may also result in unintended consequences. There is growing awareness on the part of some physicists that the experiments carried out at the LHC might be unlocking more than just insider information about the universe. It's possible that they're revealing new forces or dangers that humanity is not yet able to deal with. One of the most fascinating and unsettling ideas in this regard is the concept of vacuum decay. According to this theory, under certain conditions, the energy produced by the LHC's particle collisions may cause the fabric of space to undergo a catastrophic shift, setting off a series of events that could alter the nature of reality itself. Whereas the probability of this happening is extremely low, the potential repercussions are so severe that it poses a danger that, according to some, should be considered carefully. If a vacuum decay event did occur, it could cause the universe to collapse as we know it, leading to the destruction of all energy and matter within the universe. Despite the speculative nature of these issues, the LHC remains a focal point for scientific investigation. The exhilaration concerning the potential for new discoveries frequently surpasses the warning voices heard every day by thousands of scientists at CERN, who put in a lot of effort, driven by a strong desire to learn more about the fundamentals governing existence. However, due to the LHC's cutting-edge operation, the ethical implications of such potent experiments continue to be a subject of ongoing debate. An additional area of concern is the possibility of creating phenomena that we do not fully comprehend. The LHC has already exhibited the capacity to create exotic elements, like the Higgs boson, that had previously only been speculated about. However, this capacity to develop novel forms of matter also raises the question of whether we might produce particles or entities that could pose unexpected risks.